Hello and good day to everyone. My name is Muhammad Shafiq bin Kasmazudi and my matrix number is AE190107, and today I will show you the simulation about our assignment topics. So this is the variable view, which is our X and Y, rotational speed, and also torques. And this is the data view, which we have 100 numbers of data view for rotational speed and also torque. So next for the simulation. So this is the output that we will get for our equation. First, for the frequency. In this frequency, we need to find mean, median, mode, standard deviation, minimum, and maximum. So to do that, first we need to click analyze, go for descriptive statistic, frequencies, get the variable which is rotational speed and torque, click the statistics, click the information that we want. So I click for this, minimum, maximum, standard deviation, variance, mean, click continue, and click OK. And then you will have a output like this statistic here. And next for the graph. For the graph, click the graph here, go to chart builder, OK, and then choose a scatter dot, click the first one graph here, and then for the y-axis, pick the top for the y-axis and rotational speed for the x-axis. And also for the title, you also can change or make the customs, or you can write anything that you want for the title. And from here, I write torque versus rotational speed here. Then after that, you click OK, then you will have the output like this. And next for the regressions, you click analyze, go for the regressions, click linear, and then get torque for dependent and rotational speed for the independent, and go for statistics, click the all box here, click continue, and press OK. And then you will get descriptive statistic, correlations, variable enter remove, model summary, ANOVA, coefficients, and collinearity diagnosis. And next, for the t-test. For the t-test sample, click for the analyze, go for compare means, go to one sample t-test, get the test variable which is rotational speed and also torque, click for the option and make sure that our confidence interval percentage is 95%. Click continue, and here is the main part, which if the question asks the test value is 0, then you click OK. But if the question asks the test value is 1, so you need to change the test value here into the 1. Click to 1, and then OK. Then you will have the output like this. So here is the one sample t-test for test value is equal to 0, and here is the t-test for the test value equal to 1. And also, we also use the Microsoft Excel to do the manual calculation to find this one, SSY, SX, SYY, beta 1, beta 0. So this is all the formula that we done before. So that's all for me. Thank you.
Okay, Assalamualaikum. My name is Ahmad Yakim Muhammad. So my matric number CE190053. So for the calculation that we find the means and the deviation and minimum and maximum value for the independent and dependent variable. So for independent variable, we got the rotational speed, and the dependent variable we got torque. So this is what we get for the comparison. Rotational speed, SPS, we're using SPSS and Excel. So for the mean, we got 1545.2400, and for the Excel we got the 1545.24, and for the standard deviation we got 205.55071, and for the Excel we still get the same value, which is 205.5507075. And for the top we got for SPSS and for the Excel we get 39.0580 and 39.508. And for the standard deviation we got 10.06976, and for the top we got 10.06976.352. And that's the comparison between SPSS and Excel. So the data has been proven by the manual calculation, and this is the calculation for the mean. We got 1545.2400, and the variance we get 110.4544.49. And standard deviation we got 205.55071, and for the minimum value for X is 1306, and for the maximum value we get the 2861.00. And same for the mean for the dependent variable, which is torque. We got y 39.0580, and the independent variable we got the 166126.8, and the standard deviation for independent variable we get 10.606976, and minimum value is 4.6, and the maximum value is 65.70. And this is the diagram for the scatter graph, scatter diagram, and this is calculation for coefficient table. We got SXY equal to negative 177655, and for SXX we got 4182858, and SYY equal to 16038.6136. And this is our last calculation. We got 105.138 minus 0.042x. I think that's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Fikir Hadis. I'm number matrix 810041. Right now we are explaining about the test the hypothesis whether the slope is equal to HO E1 equal E1 against unequal to 1 by taking 5% level of significance. This is the table of one sample statistic, and this is for the table of one sample test. Then first we need to do the hypothesis test. HO B1 equal to 1, H1 B1 not equal to 1. Step 2, we just use this variable and use this formula, and we put the formula, the value, and we got this. It reaches HO when t-test is more than 1.984 or less than negative 1.984. And step 3, we compare MSE and t-test, and we put the value that we got from above, SSY, SSX, and SYY, B0 and B1. Then we calculate the SSE, and we get this, and then we calculate the MSE, we put the value, and we get this. Then the last part in t-test, we use this formula and put the value into the formula, and we get this. And the step 4, we need to decision. The decision is do not reject HO since t-test 1 is less than 1.984. Step 5, we can calculate the slope is equal to 1. Next, test the hypothesis whether the intercept is equal to 0 against unequal to 0 by taking 5% level of significance. First, we have to do the step 1 to 3. We test 1, we put this formula and put the value, and then we get this value, the answer. And step 4, we make the decision, we reject HO since t-test 1 is less than 1.984. And step 5, we conclude that the intercept is not equal to 0. And the next one, we explain it. We compute the coefficient of Pearson correlation and interpret the meaning. We have to interpret the meaning because there is a correlation between these two variables. This is the table of correlation. Then we will calculate the R, and is the formula. We just put the value into this formula, and we get this. So the correlation is negatively strong linear relationship. I think that's all from me. Thank you.
My name is Karthik and my metric number is CE190125. I will present about the coefficient of determination and interpret the meaning. Okay, from the table shows, we can see the model summary of our data. The praise coefficient determination R2 is used to describe how statistical analysis is measured. Greater the percentages will cross over the line when the coefficient is higher. To find the R square, we have to use this formula and we get 0.7516. Then we have to square root the answer to get the R value. 0.867 is our R value, and from this we can conclude that it has a stronger linear association, and also the regression line utilizing the independent variable explains 7.64% of total variance. As a conclusion, there were hundreds of data were collected to complete the data analysis from any internet sources based on engineering. And the second one is the students were able to learn how to use the SPSS software to obtain result and solve the problems involving the sampling distribution, hypothesis testing, and simple linear regression for population means. From the slope, we can see the negative linear relationship between the value rotational speed and the torque. The Pearson coefficient correlation is R equals to negative 0.86, which is proven that the association between two variables is very strong. That's all from us. Thank you.